usually speak of Einstein's theory of relativity in the singular form, but actually Einstein made two theories of relativity. But since the second theory includes the first one, it still makes sense to just talk about the one theory of relativity. But it also makes sense to talk about two theories of relativity, since they use different geometries and are quite different. The special theory of relativity, the first one, abbreviated SR, was made by Einstein in 1905. It's a theory of time, but it describes only even motion, so not accelerating motion, just this even motion when something moves in the same speed at all times. Whereas the general theory of relativity, GR, that Einstein made in 1915, is a theory of time which includes accelerating motion. And Einstein discovered that the same things he said about accelerating motion also could say about gravity, so this is a theory about both time and gravity. We are going to focus on special relativity here because it's simpler and it gives us all the interesting main facts about time that we need, and then we'll include some stuff from GR when it's relevant. So then, this theory of special relativity consists of two main claims. So the two main claims then that are the most important for the whole theory of relativity. The first is that the laws of nature are the same in all inertial frames of reference. So again, inertial is this non-accelerating frame then, when it's even motion. And we are used to this fact. That's not a very surprising fact. We know that that the laws of nature, they are the same if you are sitting still or if you are, for example, sitting on a train and it's in even motion. And things will happen in the same way. If you drop a ball on the floor, for instance, it will drop straight down regardless of whether the train is standing still or in even motion. So that's the first claim. But the second claim was the new and surprising thing, namely that the speed of light in a vacuum, not if it's moving through a medium like water, etc., but in vacuum, is measured to be the same value. And this is abbreviated c, that's the speed of light, that's just an abbreviation for the speed of light, in all inertial frames of reference. So people moving, if they're moving in an even motion, then they will measure the same light speed, regardless of whether they are moving quickly towards the light or with the light, or regardless of direction. And that's a unique thing for light, because what we mean is that compared or relative to themselves, they will always measure the same light speed, and that's not the same if that's not the case if you are measuring the speed of a car relative to yourself. It will depend on whether you're moving along on the side of the car or towards the car or standing still, etc. So this is a unique fact about light. And the first claim was, well, it's not common knowledge at all times, but it was Galileo who discovered this at around 1600 when they were discussing whether the Earth moves around the sun. And people couldn't believe that, because they said, well, we can experience that we are standing still. If we had been moving through space thousands of kilometers per hour, then we would have noticed. But Galileo said, well, think about it. If you're on a boat, under deck, curtains, you can't see out, etc., then it's difficult to know whether the boat is standing still or moving. And it's the same with Earth. We could be moving through space thousands of kilometers per hour. If it's an even motion, then we wouldn't notice the difference between standing still or being in high motion or high speed. So that's the principle of Galilean relativity, you could say, the first principle, which has been known then for hundreds of years and is common knowledge. But the second claim, there was a physicist called Maxwell who said that this speed of light is the same in all frames of reference, and And Einstein developed then this into a full theory that has been confirmed. And that's a big surprise because it means that the universe has to make all sorts of adjustments, changing how people experience time and motion and how things contract, etc., in order to make it the case that everybody measure the same speed of light. And why does the universe do this strange thing? There's no theory about that. That's just, if you ask a physicist, they'll only say, well, that's just how the universe is, but it's a very strange and surprising fact that the universe would make all these adjustments in order to make it the case that everybody measures the same speed of light. And it has a lot of interesting consequences, and we are going to look at them in the following videos.